Hi, I'm really sorry I can't be here with you today, but we're still going to cover some content and we're going to start our second learning target, which is about applying the law of conservation of mass in order to balance chemical equations. But before we get started, I need you to take out your green unit organizer so we can fill in slot 5, 6, 7, and 8. And don't forget the points possible. You should pause the video and fill that in now. The note sheet should look like this. It should be titled Balancing Chemical Equation Notes. And there's 4 basic things we have to remember before we can start balancing chemical equations. And the first is that a balanced chemical equation shows the types of substances in the chemical reaction and the amount of those substances. The second is that the chemical formulas of the reactants and products must be written correctly, and that's where all that practice with those ionic compound formulas comes in. That's why you've been having a ton of warm-ups with those. We also need to remember that numbers are used to balance substances. These numbers are put in front of those symbols and formulas, and they're called coefficients. The last and most important thing we need to remember is that the law of conservation of mass applies to balancing chemical equations. In fact, that's what you're being assessed on. So we need to remember that the number of atoms of each element on the reactant side, or the left side, or what we're starting with, will be equal to the number of atoms of each element on the product side, or the right side, or what we're ending with. So in lay terms, if we're starting with 5 atoms of oxygen, we need to end with 5 atoms of oxygen. Now that we have those basics down, there are 2 key rules for balancing chemical equations. The first and most important is that you will never change the chemical formula or those subscripts for the reactants and products, because that gives us kind of the recipe of what we're working with. The only thing you will change are those front numbers, or those coefficients, because we can change the number of molecules or how much of something we put in, we just can't change what it is. So let's balance a chemical equation together. We're going to balance this one first. This is iron oxide creates iron plus oxygen. Now this is very obviously unbalanced. Let's do an atom count to prove that. On the left, or the reactant side, I have 2 atoms of iron and 3 atoms of oxygen. On the right, or the product side, I have 1 atom of iron and 2 atoms of oxygen. So I have 2 elements I have to balance because neither of them are equal. But where do I start? Well, there's a trick to that. We're going to find the least common multiple, which is the smallest number each element will have in common by using multiplication. So in order to find the least common multiple for iron, we're going to take the 2 atoms we had on the reactant side and multiply it by the 1 atom of iron on the product side. And that gives us an answer of 2. For oxygen, we're going to multiply the 3 atoms we have on the reactant side and multiply it by the 2 atoms we have on the product side. And this is equal to 6. Well, great, but where do we go from here? Our next step is to select the element with the largest least common multiple. That would be oxygen, because 6 is bigger than 2. That means for our starting point, we need to try to get 6 atoms of oxygen on each side of the equation to start. So before we go any further, I'm going to bring down that atom count from above. You should as well, because I need to take you through that thought process of balancing those equations. So my first step is to get 6 atoms of oxygen, but I can't change these subscripts. I can only put a number in front. If I start on the left, I have Fe2O3. Okay, so in 1 molecule of Fe2O3, I have 3 atoms of oxygen. My goal is to get to 6, and I need to think, what times 3 is equal to 6? And the answer is 2. So I'm going to put a 2 in front. So if I do 2 times 3, I'm going to get 6 atoms of oxygen. Nice, way to go. And now I'm going to do the same thing on the right. If one molecule of O2 has 2 atoms of oxygen, then 3 molecules of O2 will have 6 atoms of oxygen. But wait a minute, those ions aren't done yet. I know, that's the next step. So let's bring down this atom count again. And I'm going to write the same thing I had right above it, even those crossed out numbers. I got to bring down those coefficients as well. Now here's the deal. A lot of you might have been saying in the last step, wait a minute, if you're multiplying 2 times 3 to get 6, what about 2 times 2 to get 4? Well, you're so right, because now I have 4 atoms of iron on the left, but I only have 1 on the right. So I need 4 here in order to make 4 atoms of iron on the right. And right now, we're balanced. We have the same number of atoms of each element on both sides of our equation. Now let's do 2 more together, kind of getting rid of that kind of step-by-step boxes. But if you get confused, you should pause the video, rewind, and reference your note sheet. Now, the first step to solving any balanced equation is to do an atom count. So on my left, reactant side, I have 1 atom of zinc and 2 atoms of oxygen. On the right side, it looks like I have 1 of each. Now I need to find my least common multiple. Well, zinc is already balanced. It's the same number. But oxygen isn't. I have 2 on the left. I'm going to multiply by 1 on the right, which is equal to 2. So which element has the largest least common multiple? Well, oxygen does. I need to try to get 2 on each side because that was my answer here. Okay, I already have 2 on the left, so that's taken care of. But in order to get 2 atoms of oxygen on the right, I need to put a 2 here because the only thing I can do is change these front numbers. I can't put a little number here. So in order to get another atom of oxygen, I had to add a whole nother molecule. So now I have 2 of each on the right side. Am I balanced? No, because now my zincs are out of whack. So now looking over here, I have 2 atoms of zinc on the product, but I only have 1 here. Well, luckily for us, zinc has a subscript of 1. So if I just put a 2 in front of zinc, that means I have 2 zinc atoms. If I look at my atom count now, I have 2 atoms of zinc on both sides of my equation and 2 atoms of oxygen on both sides of my equation. So I'm balanced and I can move on. You can put a 1 here if you're comfortable, or you can leave it blank if it's only 1 molecule of it. Either way, it's correct. This is the last one we're going to do together. So let's do the atom count. On the left, I have 1 atom of boron and 2 atoms of fluorine. On the right, I have 1 atom of boron and 3 atoms of fluorine. So obviously 1 is out of whack, but we're going to do the least common multiples anyway. So boron, same number. It's already balanced. But let's find the least common multiple for fluorine. So I have 2 atoms on the left times 3 atoms on the right, and that equals 6. So which element has the largest least common multiple? Fluorine does. So my goal is to get 6 atoms of fluorine on each side, because that's my answer here. Let's start over on the left. If 1 molecule of F2 has 2 atoms of fluorine, in order to get 6, which is my goal, I'd have to put a 3 in front, because 3 times 2 is 6 atoms of fluorine. Alright, let's do the right. If 1 molecule of BF3 has 3 atoms of fluorine, then I need to put a 2 in front of this one, because 2 times 3 atoms of fluorine is 6. So now our fluorines are balanced. But wait, we put a 2 in front of boron too, so doesn't that change that amount? It does. Now, in 1 molecule of BF3, there's 1 atom of boron. But in 2 molecules of BF3, there's 2 atoms of boron. So if I have 2 atoms of boron on the right, then I also need 2 on the left. And again, luckily for us, the boron on the left has a subscript of 1, so I'm going to put a 2 in front of it. So 2 atoms of boron means there's 2 atoms of boron. So if I look at my atom count, I have the same number of boron atoms on both sides and the same number of fluorine atoms on both sides. And my coefficients are 2, 3, 2. There's one more guided practice problem, and I want you to try it on your own and then check your answers on the board. Once you're done checking your answers, I want you to refer back to the home page of the class website where the agenda is for today, or the agenda that's up on the board. By now you've watched the instructional video, and you're about to check your answer to the third guided practice section. After you've completed the note sheet, you're going to grab a colored IP sheet that's purple. You're going to complete it, check your answers, and turn it into the sub. Then you're going to follow the rest of these instructions. These pink links will take you to the simulations. I've tried to make this really, really clear, but you should ask the sub if you have any questions. Just as a friendly reminder, if any names are written on the sub notes when I attend a conference on studying the standards, which is what we teach you, there will be serious consequences. I really hope you have a great and productive class period, and feel free to email me as I'll be checking that throughout the day.